Let's dive in. I've gathered a rich set of comparison research materials that explore a fundamental and often complex topic in today's tech world. What is artificial intelligence? It's a big question. AI is everywhere, influencing decisions, powering tools, and raising new regulatory and ethical questions. But despite its prevalence, pinning down a single definition everyone agrees on? That's where things get interesting. The way we define AI matters. It affects how regulators approach governance, how standards bodies write frameworks, and how the companies building AI communicate its value and manage risk. To make sense of all this, I've reviewed a comparative set of definitions from global policy organizations like the OECD, NIST, and ISO, to major industry players like Google, Microsoft, IBM, and OpenAI. Our goal? To cut through the varied wording, extract the core ideas, spot the differences, and understand what these definitions tell us, not just about what AI is today, but where it's heading. Let's start with the formal definitions from international policy bodies, beginning with the OECD, the Organization for Economic Cooperation and Development. Their definition, updated in late 2023, has already influenced major legislation like the EU AI Act. The OECD defines an AI system as a machine-based system that, for explicit or implicit objectives, infers from the input it receives how to generate outputs, such as predictions, content, recommendations, or decisions, that can influence physical or virtual environments. The definition concludes by noting that different AI systems vary in autonomy and adaptiveness after deployment. It's a lot to take in, so let's unpack it. First, the OECD definition is highly functional. It focuses on what the system does. AI systems have objectives, which might be explicitly set or implied, and they process input to generate outputs. Those outputs, they influence real-world or digital environments. Think predictions, recommendations, decisions, all based on data. Importantly, the OECD acknowledges that AI comes in many forms. Their reference to varying autonomy and adaptiveness allows the definition to cover the full spectrum of systems, from simple rule-based programs to complex, learning-enabled models. Interestingly, you won't find terms like intelligence or learning in their definition. That's intentional. The goal is to be technology-neutral and policy-friendly. Now, how does this compare to the U.S. National Institute of Standards and Technology, or NIST? Their 2023 AI Risk Management Framework adopts a very similar definition. NIST defines AI as an engineered or machine-based system that can, for a given set of objectives, generate outputs such as predictions, recommendations, or decisions influencing real or virtual environments. It's nearly identical to OECD's. With one subtle difference, NIST uses the phrase engineered or machine-based system, placing emphasis on the fact that these systems are human-designed, even if they operate autonomously later. And while NIST drops the word adaptiveness, most analysts agree it's covered under their mention of varying levels of autonomy. So, these two, OECD and NIST, are converging around a functional, behavior-based definition. They intentionally avoid discussing AI in human terms. No mention of intelligence or thinking. Instead, they focus on goals, outputs, and impact. Now let's look at ISO, the International Organization for Standardization. ISO adds a unique angle. First, they define artificial intelligence as the research discipline, not just the system. Then they define an AI system as an engineered system that generates outputs such as content, forecasts, recommendations, or decisions for a given set of human-defined objectives. That's the key difference. ISO specifies human-defined goals, reinforcing accountability and traceability in technical standards. Also, ISO doesn't mention autonomy or learning in their core definition, though these concepts are covered elsewhere in their standards. What's notable is ISO's inclusion of the terms narrow AI and general AI, explicitly defining weak AI as task-specific and strong AI as broadly capable, aligning with common industry terms. From here, we'll shift to how major tech companies define AI, and we'll see a stark contrast in tone and focus. Let's now turn to how big tech companies, the builders of today's most advanced AI tools, describe artificial intelligence. Here's where things really diverge. Industry definitions tend to be more accessible, more human-centric, and full of relatable examples. They're built to connect with customers, developers, and the public. Starting with Google, especially in their cloud AI documentation, AI is often framed as enabling machines to perform tasks that typically require human intelligence. You'll see phrases like reasoning, learning, and acting, all mapped against human cognitive functions. This is an important shift. Unlike the formal definitions, Google's framing centers human intelligence as the benchmark. They also talk about AI processing data at scales that humans can't, and solving problems faster or more efficiently. Google even outlines AI's evolution using stages, reactive machines, limited memory, theory of mind, and self-aware AI. Only the first two exist today, but the staged model helps audiences grasp where AI might be headed. Microsoft takes a similar approach. On Azure, they describe AI as the capability of a computer system to mimic human-like cognitive functions, such as learning and problem-solving. They use words like sensing, reasoning, and adapting. They also adopt the common ANI, AGI, and ASI breakdown: artificial narrow intelligence, artificial general intelligence, and artificial superintelligence. And they clarify that we're currently operating only at the ANI level. IBM, one of the longest-standing players in the field, offers the most expansive definition. They describe AI as technology that enables computers and machines to simulate human learning, comprehension, decision-making, creativity, and autonomy. Notably, creativity and autonomy appear right in the core definition, which reflects the rise of generative AI. IBM also openly discusses automation and the possibility of reducing or replacing human involvement. OpenAI, unsurprisingly, puts AGI front and center. Their mission is to build artificial general intelligence. They define AGI as highly autonomous systems that outperform humans at most economically valuable work. This isn't just a description, it's a declaration of intent. OpenAI's framing is future-focused, emphasizing general capability, high autonomy, and broad impact. So across Google, Microsoft, IBM, and OpenAI, we see a consistent focus on simulating human abilities, using relatable language and emphasizing application and potential. This contrasts sharply with the formal bodies, OECD, NIST, ISO, that prioritize neutral functional definitions built for policy and governance. Now that we've walked through how AI is defined by both formal standards bodies and industry leaders, let's take a step back and synthesize what all of this tells us. First, despite the wide variety of wording and emphasis, there is a surprising amount of common ground. Everyone agrees that AI systems are engineered or machine-based. They take input, process it, and generate outputs, typically predictions, decisions, content, or recommendations. And these outputs influence either physical or digital environments. Another shared element: goal orientation. Whether explicitly stated or left more ambiguous, all definitions involve AI systems operating with a set of objectives. There's also universal recognition that AI systems vary in how autonomous or adaptive they are. This allows definitions to apply to everything from simple rules-based tools to complex learning systems, without needing to label them as narrow or general AI. But of course, the differences matter, and they tell us a lot about the priorities behind each definition. Formal standards like those from OECD, NIST, and ISO aim for policy precision. They carefully avoid philosophical or emotional language like intelligence, learning, or thinking. Instead, they favor function-based language that can be reliably interpreted across legal and technical domains. These definitions are designed to support regulation, compliance, and risk management, which is why they're so relevant to our audience in legal and TPRM roles. In contrast, industry definitions from companies like Google, Microsoft, IBM, and OpenAI are all about accessibility and impact. They lean heavily on comparisons to human cognition, using terms like mimic, simulate, or replace human intelligence. They want customers and developers to understand and trust what AI can do. And then there's the future focus. Most formal definitions are deliberately built to be flexible, covering today's systems while allowing room for tomorrow's innovations. But they stop short of addressing artificial general intelligence head-on. Industry players, especially OpenAI, are more explicit. They talk about AGI as a mission, not just a possibility. They frame AI's evolution as a progression, from narrow to general, and potentially superintelligent, with real-world implications for economics, labor, and governance. So, what does this mean for professionals in legal compliance and third-party risk? It means we have to be fluent in both languages. We need the precision of formal definitions to build policy, assess vendors, and manage AI-related risk. But we also need to understand how companies describe and market their AI, because that's what shapes adoption, usage, and public perception. This dual fluency is especially important when evaluating vendor claims, drafting contractual obligations, or designing governance frameworks. Understanding both the standards and the storytelling around AI gives you the full picture. And finally, one provocative question to leave you with: if or when AI systems truly surpass human capabilities in broad domains, will these functional definitions still be enough? Or will we need a whole new vocabulary, one that goes beyond artificial intelligence? That's something to keep in mind as the technology and our governance of it continues to evolve. Thanks for listening.